You got it? Okay, so the question is, we have nitrogen monoxide gas reacting with carbon dioxide, giving you nitrogen dioxide and carbon monoxide.
What number is this?
This is number 5C.
5C on 13.2.
Okay. Now, the initials that they gave you was for the nitrogen monoxide, we have 0.00100 molarity. For carbon dioxide, we have 0.00100 molarity, and then the products are 0 because it hasn't reacted yet. Okay, they also gave you a K equivalence of 0.25, right? 250. Now, from this K equivalent, what do you automatically know? Which way is favored?
Favors the reactant.
Favors the reactant side because it's less than 1, right? If it's greater than 1, it would favor the product side. Now, what they want to know is so right now, have we done anything? No, they have not mixed yet. So the question is, once we mix it and we let the reaction proceed for a while, what will be the end concentration, the equilibrium concentrations? That's what they're asking. Does that make sense? So think of it this way. Right now, we're going right over here. Right now we have nitrogen oxide and CO2, right? Now we're going to put them, they're gas. So when we put them together, we're going to get NO2 plus CO. Does this make sense?
Mm-hmm.
As the reaction proceeds, what's going to begin to decrease? Think about it. These two are reacting together to form this, right? So as they react with each other, what's going to start happening? What will be the change that you'll see?
CO2 will decrease.
Yeah, so these will begin to decrease, and these will begin to increase, right? Initially, at least, right? Until it reaches equilibrium. Now, how much will it decrease by? Do we know?
No.
We have no idea. So let's just give it a variable. Let's just say that NO decreases by X. Now, what is NO reacting with? CO2. And what was this balance real quick?
Yes,
Yeah, balance. Okay, so we gotta make sure it's strong. So for every NO, anytime you lose an NO, don't you lose exactly one CO2?
Why?
Because they're reacting with each other. Who's this NO reacting with?
CO2.
CO2. So can a reaction occur without them bonding together? So for every NO2 that you lose, how many COs do you lose? 1. So if this is minus X, then what is this? Minus X. You guys following?
Yeah.
Now, if this is decreasing by X, well, what is this increasing by? The same exact amount. So this is going to be plus X and plus X.
Okay.
Are you guys following now?
Yeah.
Okay, so that's my change. What will my N equilibrium values be? Well, NO, they started off at 0.00100, right? Minus X, right?
Yeah.
And this is what? 0.00100 minus X. You guys see how I got that?
Oh my god, this is not that bad.
Wait,
Yeah, it's not that bad, huh?
Yeah, no.
And so what's this? What would this be? What would be the concentration of the NO2 in equilibrium? X and X. Now let's write the K equilibrium. What's going to go on top? The concentration of NO2 and the concentration of CO. There's no coefficient, so this can be to the 1 power, right? And what am I going to divide this by?
The concentration of NO and CO2.
Now, remember what I mentioned earlier? K equilibrium only applies to what?
Oh, not watering.
Huh?
Only,
Only applies to the equilibrium state. So the only numbers I can plug in is this one, K equivalent. K equilibrium, sorry. Does that make sense?
Those are all of them.
Huh?
So you can plug
Yeah,
all
all of them, good.
Oh.
So what am I going to plug in? What was NO2? X, right?
Mhm.
So I'm going to plug in X for that. What was CO?
X.
X, so this is times X. Now, what was our NO? 0.00100 minus X times 0.00100 minus X. You guys all following?
Yeah.
And what is this? What is the K equilibrium equal? 0.250. So this equals 0.250. Is everybody following?
Wow.
So now it's algebra. So this equals what? This equals X squared. Now I know normally you want to FOIL this, but you don't need to because it's exactly the same. This equals 0.00100 minus X squared. Does everybody see how I did that?
So you square root of all that first.
So square root everything. You square root this, you square root that, you square root this. What do we get? We get X over 0.00100 minus X equals 0.5. Now what are we going to do? However you see it, if you like to cross multiply,
Yeah.
or if you just want to multiply by 0.001, it's your personal style. Okay? So we're gonna the way I like to see it is we cross multiply, right? So that's going to be x equals 0.5 times 0.00100 minus x. And now I'm going to distribute it. Everybody sees that? So what do we get then? You get 0.0005, right?
I got 5 times 10 to the power negative 4.
Yeah, it's 5 times 10 to the power negative 4, right? Minus 0.5x. So then I'm going to do plus 0.5x, right? Plus 0.5x. And this is a 1, right? So this is going to be 1.5x equals 0.000500. And I'm going to divide by 1.5, and I'm going to divide by 1.5. So what's my x?
0.5, right?
No, because I added by 0.5. So this is a 1. So 1 plus 0.5 is 1.5. So we'll divide by 1.5. What do you guys get?
3.3 times 10 to the power negative 4.
So 0.00330.
Can you write it in scientific notation?
Yeah, it's fine. You can write this. If you would like, you can write this 3.30 times 10 to the negative 4. It's fine, either way. So now what does that mean? My x is what? That's my x, right?
Yeah.
So what am I going to do now? Is that my answer? No.
Plug it in.
That was my x here. So now you plug in for x. Wherever you see x, you put that in there. So this is going to be 3.33 times 10 to the negative 4. And so what is this? 0.00100 minus what? 3.33 times 10 to the negative 4. Right? And so this is automatically 3.33 times 10 to the negative 4. So you got the concentrations. What is 0.00100 minus 3.33 times 10 to the negative 4?
Um, 6.67 times.
So
times
good.
the
So we have
negative
6.67 times 10. So this is our equilibrium concentration, and it's all molarity. Got it?
Wait, wait, wait.
Woo!
Wait, where'd you go?
Hmm?
You